everyone, it's Mahesh Shirur. Today I am going to explain you the turbines related to the Francis turbine of Model 5 applied hydraulics. Okay, so this is the before that I want to tell you what is meant by Francis turbine. The inward flow reaction turbine having radial discharge at inlet is known as Francis turbine. In the modern Francis turbine, water enters the runner in a radial direction at outlet and leaves in an axial direction at inlet. Thus, the modern Francis turbine is mixed flow turbine. Okay. So this is the main components and its application discussed in this article. So Francis turbine here the center the runner will be there. Then after runner a drift tube is fixed and to this tube here there is a steering and guide vanes, spiral case, water guide devices, operating ring, main shaft at the center, water inlet, hand cover, and lastly guide vane. This is the components of the Francis turbine. The working principles are the Francis turbine is a combination of both impulse and reaction turbine where the blades rotate using both reaction and impulse force of water flowing through them, producing electricity more efficiently. Francis turbine is used for the production of electricity in hydro power stations. Majorly, there are two turbines flow pattern on which they work, namely radial and axial flow concepts. An American civil engineer by name James B. Francis in Lowell, Massachusetts, comes up with an idea of combining both impulse and reaction turbine where water enters the turbine radially and exits radially. The main reason of high efficiency of Francis turbine lies in the design of blades. These blades rotate using both reaction and impulse force of a water flowing through them. Due to the use of this type of a turbines, the main problem faced due to the water head availability is eliminated as the turbine use both the kinetic and potential energy to produce power. So in this Francis turbine, both kinetic energy and potential energy are used to produce a power. For this, it is also known as mixed flow turbine because of kinetic and potential energy. It is called as mixed flow turbine. The other name of Francis is mixed flow turbine. Next, The main components of Francis turbine are spiral casing, stay vanes, guide vanes, runner blades, and draft tube. So first one, spiral casing. The spiral casing is the inlet medium of a water to the turbine. The water flowing from the reservoir or dam is made to pass through this pipe with a high pressure. The blades of the turbines are circularly placed with the mean of the water striking the turbine blades should flow in a circular axis for efficient striking. So this spiral casing is used, but due to circular movement of the water, it loses its power. To maintain the same pressure, the diameter of the casing is generally reduced so as to maintain the pressure uniform. Thus, uniform moment or velocity striking the rubber blades. Next one, stay vanes. Second part of the turbine is stay vanes. Stay vanes and guide vanes guides the water to the runner blades. Stay vanes remain stationary at their position and reduces the swirling of water due to radial flow as it enters the running blades, thus making the turbine more efficient. So this is the figure of stay vanes. So here parallel stay vanes has been fixed to this central arm, and here guide vanes are there inside the stay vanes, and water will be entering to the pipe in this arrow direction. So figures to stay vanes and guide vanes of the Francis turbine. So next one is guide vanes. Guide vanes are not stationary. They change their angle as per the requirement. To control the angle of the striking of the water to turbine blades to be increase the efficiency. They also regulate the flow rate of water in running blades, thus controlling the power output of the turbine according to the load on the turbine. So next component is for the runner blades. The performance of the efficiency of the turbine depends on the design of the runner blades. In a Francis turbine, runner blades are divided into two parts. The lower half is made in the shape of small bucket as that it is uses the impulse action of water to rotate the turbine. The upper part of the blades uses the reaction force of the water flowing through it. Thus two forces together make the runner to rotate. Okay. Then next one is the draft tube, fifth component of the Francis turbine. The pressure at the exit of the runner of reaction turbine is generally less than the atmospheric pressure, that is nothing but air pressure. The water at exit cannot be directly discharged to the tail race. A tube or pipe of a gradually increasing area is used for discharging the water from the exit of the turbine to the tail race. Thus, tube of increasing area is called as a draft tube. One end of the tube is connected to the outlet of the runner, and while the other end is submerged below the level of the water in the tail race. So next one is, how does a Francis turbine work? In this, the water is allowed to enter into the spiral casing of the turbine, which led the water through the stay vanes and guide vanes. The spiral casing is kept in the decreasing diameter so as to maintain flow pressure. The stay vanes being stationary at the place removes the swells from the water which are generated due to the flow through spiral casing and tries it to make the flow of water more linear to the deflected by adjustable guide vanes. The angle of guide vanes decides the angle of attack of the water at the runner blades, thus make sure the output of the turbine. The runner blades are stationary and cannot pitch or change their angles, so it's all about the guide vanes which control the power output of the turbine. The performance and the efficiency of the turbine is dependent on the design of the runner blades. In a Francis turbine, runner blades are divided into two parts, that is, the lower half is made in the shape of small bucket, as that it uses the impulse action of water to rotate the turbine. The upper part of the blade uses the reaction force of the water flowing it. Thus, runner blades make use of both pressure energy and kinetic energy of water and rotate the runner in most effective and efficient way. The water coming out of the runner blades would lack both the kinetic energy and pressure energy, so we use the draft tube to recover the pressure as it advances towards the tail race. But still, we cannot recover the pressure at the extent that we can stop air to enter into the running housing, thus causing cavitation. So lastly, application of the Francis turbine. Francis turbine is the most widely used turbine in hydropower plant to generate electricity. Second point, mixed flow turbine is also used in irrigation water pump set to pump water from the ground for irrigation. Third point, it is efficient over a wide range of water head and flow rate. Last one, it is most efficient hydro turbine we have till date. Thank you.